Alright, ladies and gentlemen, today we're going to be talking about the last part of our series on balancing chemical equations. We're going to be doing part 3. We're going to be doing some more extensive chem balancing today, and so we're just going to head right into it. Here's some tips I'd like for you to remember as we're going through these, and we'll remind you as we go through. First tip, you may only work on the coefficients, the numbers in front of the molecules. You can never alter the formula itself. Remember, if you change the subscripts, you're changing what the compound is, not how much of it you have. Also, balance the complicated ones first, the ones with multiple elements, and then you can do lots of the different elements, work on those first. And then leave the molecules representing the elements by themselves until last. So like H2 or O2 or N2 or whenever the element is by itself, that's what you want to work on last because they're the easiest. They don't affect any other elements in the balancing process. Okay, to start us off, we have copper chloride and H2S. That would be a sulfur hydroxide or something like that. And then we got Okay, to start us off, we have CuCl2 plus H2S yields CuS plus HCl. We have copper, chlorine, hydrogen, and sulfur in each side. We want to make sure all of those are balanced. This is a lot of elements, a lot of things we need to do, and so we need to make sure we go step by step. We're going to first start off by labeling how much we have on each side. So we have 1 copper, 2 chlorines, the subscripts tell us that, and then we have 2 hydrogens and 1 sulfur. Here we have 1, 1, and a 1, 1. We have all those there, and so we have these chlorines and hydrogens that we need to work on. And so we look here, we have chlorine 2, we have Cl2 over here, and so let's just start off by putting, trying to get 2 chlorines on this side. So we got 2 chlorines. We're going to change that from 1 chlorine to 2. But now we also have 2 hydrogens that we need to work on. And so let's see if that works here. We have 1 copper chlorine, CuCl2, good, 1, 2, and 2, 1. Wow, that works great. And so now we have this balance where we have, all we did was we changed 1 subscript. It's not always going to be that easy. We're going to look at one next. It's going to be a little bit more difficult. Here's a reaction that is a little bit difficult, and once we get through this and walking through it, if you need to rewind back and look at why we're doing the things that we're doing, it'll make more sense. But right now we have a combustion reaction. We have C2H6 plus O2 yields CO2 plus H2O. So we're going to first start out by writing out our molecule or our elements on each side. We got 2 over here of carbon, 6 and 2. Here we got 1 and we got 2 hydrogen, and then we have 1, 2, and 3. Alright, that makes things a little bit difficult because we have an odd number over here and an even number over here and an even subscript. That means that anything on this side should be even. I need to remember that in order for us to even get a chance to balance it. And so that will make things a little bit more difficult. And so a lot of times I like to think of like multiples of numbers and subscripts to think about here. So let's start out by first just getting one of these balanced. Let's start out by doing 2 carbons over here. And we got 2, and then that's going to change this oxygen to 4, 5. Now right now that doesn't get us there, but now we have at least the carbons set up. Now that might change as we go through. But now we're looking at the hydrogens. And if I were to try this as I would, okay, I see I need 3 as a coefficient, and so that's going to give me 6. But then that's not going to change over here. That's going to change us from 4 to 7. That is not going to work as it is because there's no way I can make a coefficient to equal on this side. I can't make that equal 7 in the end. There's no way I can make that equal 7. And so what I need to do is I need to start working on this side on the reactance side to see if there's a way I can manipulate the hydrogens and the oxygens in order that they can work out. So what I might do is I'm going to try to double this side, and we'll see how that affects everything here. That's going to change this to 4, and then it's going to change our hydrogens over here to 12. And so now I need to alter this back, and so now instead of 2 I got 4 carbons. And that's going to make 8 plus 3, and that's going to make it 11. Okay, so what I want to do now is, since I have 6 over here, I need to get 12. So I'm going to change that. Instead of 3, I'm going to make it a 6. I'm going to double it, so now I have 12 hydrogens. And I have 6. I'm going to start off by erasing the O's, and now I have on the CO2 I have 8 oxygens, plus now I have 6 oxygen. So that's going to give me 14. Now 14 is an even number. That's going to give us an opportunity to balance out the oxygens on this side over here. So I would do 2, my subscript, times a number, and that's going to give me 14. And our number is 7. Okay, so let's double check here. I got 4 C's. This gives me 12 hydrogens, and then we have 7 oxygens, or 14 oxygens over here. And we have 4, 12, and 14. So right now we are balanced. So as you can see, a lot of times it's a lot like putting a puzzle together, that sometimes you have to be a little bit creative and guessing and checking to see things that work before they balance out. So this is one of the more difficult reactions that you would get. What I'd like for you to do is I would like for you to, after watching this video, get some practice by looking at Jefferson Lab, as well as another site right below it where it has the balances, and it will check it for you. And then please continue following on the Google Doc to finish our lab. And that is part 3 of chemical balancing of equations.